Yo, what is up, beautiful people, and welcome to this channel. If you clicked on this video, then you're probably wondering, like, Nani, what is this all about? Well, that's a good question. So what I wanted to do with this channel was just create a bunch of videos, tutorials mainly, involving game development, because I've always wanted to create a game. I don't have any game development experience, but as a kid, it's always been my dream, and I'm no longer a kid now, but take the words of Uzumaki Naruto and follow your dreams. Become Hokage, become a game developer, do whatever you want to do. And this is what I've always wanted to do. So here we are. I'm hoping through the tutorials, through teaching you guys, that I could teach myself these things, these skill sets, and eventually come up with the game at the end of all of it. So with that said, I hope you enjoy the journey and enjoy the ride. And let's make a game. That was a nice snap, boy. What's up, everybody? So here we are in Unity, and this is the first screen that you're gonna see after creating a Unity project. In our case, we're creating a 2D game because we're focused on a 2D top-down player movement tutorial. That was kind of a handful to say, but moving on, let's just take a quick look at the UI. I won't be explaining too much about it, but you'll have your toolbar at the top, you have your hierarchy on the left hand side of the window, and then you have your scene view and your game view in the middle, your inspector on the right, and then you have your projects folder at the bottom. Going through all of the tools that comes with Unity would kind of be its own separate video, but for now we want to focus on player movement. So to do that, we first need a player or a game object. So to create a game object, we right click in the hierarchy field, and then we scroll down to 2D objects because we're doing a 2D game. We go to sprites, and then we create a square. In our case, it could be any shape you want. You could put in your own sprites, but for this video, we're gonna go with the square. And then you'll see that a square shows in the scene view. And then when you click that square, you'll see inside the inspector, there's a bunch of information that you can do. Think of this as kind of like a metadata that's associated to this particular game object or to this particular square. If we were to click play, and then we're supposed to press buttons and the square is supposed to move, but nothing's happening. I'm pressing WASD. If you're a pro gamer like me, nothing's happening. So we gotta really ask ourselves why. Why is this the case? The reason why this is happening is because there is no functionality applied to this game object. So we need to apply functionality. How do we do that? So to apply functionality to this square, we got to create a script. And script, a lot of people are intimidated by scripts because it involves programming, but I will do my best to explain to you what's happening in every line. So what we want to do to create a script is go down to the bottom view of the projects folder, and before you create the script, you want to create a folder, because organization is key, guys. If you don't organize your stuff, I swear to God, I'm gonna whoop your ass, okay? Because so many times projects get so big and so hard to kind of manage because you don't know where any file is. So we want to organize things to the best of our abilities. So we're gonna create a folder, and we're gonna call it scripts, okay? And inside scripts, guess what's gonna go inside scripts? You named it scripts. So we're gonna go here, create a C# script by right clicking in that area at the bottom, and we're gonna name it something that makes sense to the functionality. So in this case, it's gonna be player movement or something, player movement. All right, so with this created, we could then double click on the C# script that we have, and it'll open up Visual Studios. So this is the part where you actually get to look pretty badass, because we're gonna be programming. So what we want to do is we want to create some variables that will apply to the square. When we think about movement, we have something called speed, how fast we want the square to move from one point to the other. Most people would do like we could create a float, we could do like speed, and now it equals like 5 or something. We're gonna write it a little bit differently. Okay, we're gonna make it a public variable. This way we could access it in the inspector, and we're gonna create a vector2 object, and then we're gonna name this speed, and then we're gonna initialize a new vector2, and then vector2 pretty much takes an x and a y. So we have this little plane right? You've all seen this. Y'all seen like parabolas and shit like that. Okay, y'all, don't get me into math. So you have your y-axis, right? And then you have your x-axis. So let's say we have a square right here. Hey, this is a little guy. He's filled in. And when we want to move, we either move in the y direction or we either move in the x direction. You go into the negatives if you want, and positives if you want, depending on how you're feeling that day. But this is pretty much what a vector 2 is. When you have a vector 3, you're creating another kind of path to travel, and this would be a z, right? This is z for 0, okay? Since we're only working with the 2D game, we only need to focus on up and down at the moment. Up and down could also apply to diagonal, you know, because you can move y and x at the same time. You don't always have to commit to just an x or just a y direction, right? And in this way, we could assign both x and y the speed of 5. 5 doesn't really mean anything to you guys at the moment. It doesn't really mean anything to me, but think of it as the rate at which you want your object to move when the button is pressed. We don't need start. Get that shit out of here, boy. And then we have an update. The way update works is it's called every frame. A lot of people talk about FPS. A lot of people like, yo, I'm rocking 30 FPS. I can't land this skill shot. People saying they can't land skill shots at 60 FPS. They need like 120 FPS. All those guys are just trash. But what update is, it's a function that calls every frame, right? And FPS stands for frames per second. Okay, so if you have 60 FPS, then this function would be calling 60 times per second. I don't know if you need me to write this out for you guys, but let's just do it. FPS, right, is equal to frames per second. Okay. And then the update function is called every frame. So if we have 60 frames per second, right, then this function, this update function, is being called 60 times per second. Okay, we'll leave that there. Now that we have the rate at which we want our object to move, we need to give it a direction, and direction is kind of determined by, I guess, key presses in a sense. So if we press up, we want our object to move up. If we want to go down, then we want our object to go down. And the way this is kind of done in our scenario, there's multiple ways to do this, but there's a little function called import.getAxis, and it takes a float, and it pretty much determines like, okay, if we're moving along the horizontal axis and the number is positive, then we know that we're moving right. And then if the number is negative, then we know that we're moving left, and vice versa with up and down, right? So we're going to call this import x, and it's going to read the horizontal imports. Okay, so it's going to be import dot get axis horizontal. And horizontal is not just a name that I chose to come up with. It's actually a reference inside the Unity settings. If it reads horizontal, it knows that it's referring to the right or left button presses and the A and D keys. And we're gonna do the same for import Y, where it's gonna be import.getAxis, and then this is gonna be vertical because it's gonna be up and down, right? So this right here is getting the import from the horizontal presses, and this is getting the import from the vertical, and is letting me know by determining whether it's a positive or negative number, if it's right or left, or if it's up or down. So now that we have our speed, right, and we have reference to the direction we want to move, we actually need to make our object move. We need to come up with some sort of equation where we're applying the speed to the direction. And I think the proper scientific name for that is velocity. I might be wrong. I'm not a science guy. I took English in high school, but we're going to go with that, okay? So what I'm going to do is I'm going to create a vector2, right? And inside this vector2 is gonna hold the values of x and y, and it's gonna determine whether we're gonna be moving in either x or y direction or both. And I'll explain to you how it kind of determines that. So we're going with velocity, and we're gonna instantiate a new vector2 object, right? And in the x parameter, we're gonna read input x times speed.x. And the reason why I'm able to do speed.x is because this is also a vectors too, and we could reference the x and the y parameter, right? I'm gonna have a comma here to separate the parameters, and we're gonna do the same for input y, speed.y. All right, and we're gonna times this by time.DeltaTime. Okay, and I'm gonna explain to you guys what time.DeltaTime is. But before I get there, I just want to explain what this line up to this point does. Okay, so input x tells us whether the value is either negative, right, not moving, or positive. Okay, if it's negative, we know on the horizontal axis it's moving left. If it's 0, then it's not moving. And then if it's 1, then it's moving right. Someone's gonna get bothered by this. Okay, and let me explain to you how this works. Okay, so on the x and y, we have our square. This is x, this is y. If the value of this float is negative, then we know that it's moving towards the negative side, right? We know it's moving this way, which would be left. If it's positive, we know that it's moving right. And if it's 0, then we know that this is not moving. Same thing goes for vertical. Vertical, I'm saying that right. Okay, so in this line right here, input x times speed.x, if it's moving right, then we know the value of this float is 1. And then we multiply that by the value of the vector2 x up here, right? So then we have 1 multiplied by 5. And then we're moving in the x direction at the speed at which we kind of indicated earlier. Same thing with negative. If it's -1, then we're moving at -5, right? That's just the way it goes. So then we know we're moving left at this speed that was indicated. Same thing with the y, input y. So this is what's happening over here. This is how that block of code works. Now for time.DeltaTime. So to explain time.DeltaTime, I want to show you what happens when we don't have that. Okay, I want to show you what this block of code does without time.DeltaTime, and that way you have a visual understanding of it. But to do that, we first have to actually apply our logic here, and that's just simple transform.translate, right? And what translate does, it moves the transform in the direction and distance of the translation in which we created here with the vector2, right? So we're gonna put this as velocity. So this right here is just moving in the vector2 direction. Moving in the direction determined by vector2. The direction determined by our vector2 velocity. Okay, so I kind of want to show you what's happening when we don't have time.DeltaTime being applied to our velocity. Okay, so we're going to click play, and we're gonna press gently or quickly on the right arrow key, and it's gonna kind of yeet across back and forth. And the reason why this is happening is because the object itself is moving a lot faster than what we're anticipating. So we expect our object to move 5 units per second or something, right? But that's not really happening. And the reason why this isn't happening is because the update function is being called once per frame, right? So here I wrote this little thing for you guys. So if we're moving 5 units every frame, but this frame is being called 60 times per second, then our unit is actually moving 300 units per second instead of 5, right? And the issue with this is, let's say someone's computer isn't as good and is not running optimally and is not running 60 frames, but instead is running 30 frames per second, right? So then we're gonna actually evaluate this as 5 times 30, which is 150. So you'll see here that because of the way we wrote the code, 2 people could play the same game, but because of the performance of the computer and the operating system, whatever, I don't know the term for it, they'll be experiencing different units of which they travel per second, you know, and that's kind of unfair. So the way that time.delta-time works is the interval in seconds from the last frame to the current one. So what time.delta-time is doing is that it evaluates how many seconds pass by per frame. So let's say there's 60 frames in a second and we're trying to evaluate how long it takes for 1 frame to pass. We just simply divide 1 divided by 60, and then I did the math already, but I'll do it again. That's not the math. That's not the math, bro. That's 1 divided by 60. That's 0.016, right? 0.016. And then if we're to do the same for, let's say, someone who's experiencing 30 FPS, we do 1 divided by 30, and then that is 0.033. I'm pretty sure. 1 divided by 30, 0.033. Okay. So now what we're determining is how long it takes for 1 frame to move on to the next from the previous one. And let's think of this in seconds. When it's 60 FPS, it's 0.016 seconds, and then with 30, it's 0.033 seconds. So what we're doing now is we're multiplying our speed, which is 5 units per second, and we're going to be multiplying that by the amount of time it takes for each frame to move on to the next, right? So we'll do 5 times 0.016 seconds, right? And what is that going to give us? 0.016. That's going to give us 0.08. 0.08, right? And then what's going to happen is, since the update function is being called every frame, it doesn't matter if you're experiencing 60 frames or 30 frames, it should still evaluate to 5, which is the value that we wanted it to give it initially. So 0.08 would be associated to 60 frames, and that would be 4.8, right? Equal 4.8, which is still roughly 5. And then if we were to do something like 5 times 0.033 times 30 is 4.95, right? 5 times 0.033 equals 4.95. So now if you look at it, the difference is actually only 0.15 between 60 FPS and 30 FPS, compared to when it was 150 and 300 before. So that's what time.delta-time does, and let's actually show you the effects of it. So if we go back to our code and we uncomment this, right, and then we apply time.delta-time, what happens is that, oh, I'm still playing this. Okay, what happens is that when I move the square, it moves a lot slower because of pretty much what I just explained with the math. So now if I was to go to the square and I wanted to up the speed, because I made the variable public, I could then change it in the inspector as well. So if we go back here, you see that I made this public speed, this public vector2 speed public. I can now change it in this kind of interface, and in real time you get to see that the cube itself is moving faster. And that's kind of what how time.delta time affects the movement of objects.